welcome. Today we are actually starting a new unit. We're going to be introducing functions into the mix now. Today we are going to be graphing proportional relationships. In particular, our content objective is students will be able to graph proportional relationships. Language objective is students will be able to read unit rate answers from a graph. Why am I learning this? Well, it's important for many real-life problems like finding the cost per lunch. So here we have some background knowledge from 7th grade. All I really want to get from this slide is the constant of proportionality. What the constant of proportionality is, it's basically your constant multiplier. What am I multiplying to x to give me y? So in this case, the answer is 5. My unit rate would then be 5, and again my ratio would be y over x, so it would be 5 yards per hour. Now in this slide here, I want to talk about how we would find our constant of proportionality. So in this case, I'm going to go ahead and check it out. First of all, what you need to remember is that we find our constant of proportionality if it's a proportional relationship, okay? If it is, we set it up as y over x and we check to make sure that our ratios are all equivalent. So in this case, y is 1 and x is 3. So I am multiplying 3 by 1/3 to give me 1. And then we have 6 and 2. Here, if I set it up as y over x, I would have 2 over 6. But that also would be the same as multiplying it by 1/3. Okay, and then the next one, what about 12 and 4? Well, setting up as y over x, you would have 4 over 12. That's what you multiply to give you 4, but again, 4/12 is going to reduce to 1/3. So this is going to follow through with the same. Since every single time I'm multiplying by 1/3, I'm going to say the constant of proportionality is 1/3. Okay. So we use k to represent that, just keep that in mind, and our unit rate would then be 1/3. Again, y over x would be yards per hour. Since the constant of multipliers are equivalent, this is a proportional relationship. Here, same idea, but the one thing I want to discuss here is how we graph. Well, we always use our coordinates as x comma y. So here I would graph 3 comma 12, so just quick reminder, you go over 3 up 12. Graph that point. Here 5 comma would be 5 comma 20, again over 5 up 20, plot your point. Here would be 8 comma 32, so it would be over 8, and notice 32 falls off of the graph, so that means I can't graph that point. So I'm just going to go ahead and connect the 2 points that I have. Here the line does go through the origin, which is a good sign for being a proportional relationship. My ratios would be still set up as y over x. So here I would have 12 over 3, which reduces to 4. Here I'd have 20 over 5, which also reduces to 4. And here 32 over 8, which again reduces to 4. So this means my constant of proportionality is 4. Since all the ratios are equivalent, I know it's a proportional relationship. Okay, but just by looking at a graph, you can check, hey, look, it's linear and it goes through the origin. So there's multiple ways of determining whether or not it's a proportional relationship. So our equation is y equals 4x. If you forgot, it should be following the form of y equals kx. So all that happened here was you replaced k with 4, and that's how you ended up with y equals 4x. But what does this mean exactly? Well, it means that it costs $4 per book. How did I come up with that? Well, again, it's going to be y over x, so it's going to be $4 per book. Now, moving on to the next example. Here, same idea, except now your table is running vertical instead of horizontal. You would graph it just the same. Okay, it's linear, it goes through the origin. That tells me it's a proportional relationship. When I check my ratios, they should all be the same. I'm going to set them up as y over x, so it's going to be 2 over 3. Here 8 over 12 reduces to 2 over 3 as well. And then 10 over 15 also reduces to 2/3. So since the ratios are equivalent, I'm going to say my constant of proportionality is 2/3. Therefore, I can plug it into my equation of y equals kx and say that the equation is y equals 2/3 x. But what does this mean exactly? Well, it means that there's for every 2/3 cup of blue, there is 1 cup of red. Okay, so now a little bit more background knowledge from 7th grade. How can we tell if an equation is a proportional relationship? Well, it needs to follow this form, y equals kx. So I'm going to give you some examples of y equals kx. Here we have y equals 7x, y equals 4/1x, y equals 2/3 x, y equals 5 2/10 x. All of these are in the form of y equals kx, where you basically have a coefficient and you have an x. Now, what about this? Is this a proportional relationship? Yes, because again, it's just a number being multiplied by a variable, so it follows this form. Well, what about this? Again, even though it's not y, even though it's not x, it's still in the form of y equals kx, where you have a number being multiplied by a variable in this case. What are some examples that are not a proportional relationship and not in the form of y equals kx? Here are some examples. So what do all of these have in common? Well, they have a constant. All of these constants is what's keeping it from being a proportional relationship. For example, because I have a +3 here, it looks exactly like this, but since I have a +3, it's not a proportional relationship. So now taking a look at some examples. Here it says, state whether the equation represents a proportional relationship and why. So here I would say no, it's not a proportional relationship. Why? Because it's not in the form of y equals kx, because of this constant. Well, what about number 2? Is it a proportional relationship? I would say yeah. Why? Because it is in the form of y equals kx. How about y equals 2/3 x? Well, I would say it is. Why? Again, because it's in the form of y equals kx. And then number 4, I would say this is a no. It's not a proportional relationship. Why? Because it's not in the form of y equals kx, because of this constant. Now, if this constant wasn't there, would it be a proportional relationship? Absolutely yes. So now, we're going to go ahead and move on to graphing. So here it says graph the proportional relationship. Well, since it's a proportional relationship, I know 2 things. My graph should be linear, and it should definitely go through the origin. Okay, so keep that in mind. So here, there are definitely some numbers that are a lot easier to use than others, but for this case, any number would work. I'm going to first pick the easiest number, which is 0. Okay, so here I'm going to go ahead and plug in a 0 in for x. So what does this mean? It means y equals 3 times some value you choose for x. In this case, I'm going to choose 0. So y equals 3 times 0, which is 0. I'm going to go ahead and plot this point of 0, 0 right here. That is going through the origin, so far so good. Now the next number I'm going to plug in is a 1. So now instead of using 0 for x, I'm going to plug in a 1. So here, if x equals 1, then y would equal 3 times 1, which is 3. I'm going to go ahead and plot that point over 1 up 3. Next number I'm going to choose would be the next easiest number I could think of, which is 2. So now I'm going to go ahead and plug in a 2 in for x. Now y equals 3 times 2, so I'm going to say y equals y equals 6. So I'm going to go ahead and plot that point as over 2 up 6, and there's my point. Last but not least, since I have one more slot to put an input for, I'm going to go ahead and try the number 3. So here, if I plug in 3 for x, y would be 3 times 3, which is 9. So I'm going to go over 3 up 9 and plot my point here. Now, one thing I want to mention is some students often like to draw a line but stop prematurely. Okay? When you connect the points together, you actually want to make sure you extend your line through the graph. You want to make sure it extends through the graph. Why? Because then there's other pieces of information you can collect from this graph. So definitely make sure your lines extend through. And make sure you have a little arrowhead at the end to show that it goes on forever. Because in this case, this line does not stop. So now, let's go ahead and move on to another example. Here we're going to graph just the same, but you're going to notice in this one, plugging in 0, 1, 2, 3, 4 might not be the best choice. So here, it's still going to be the same. Plugging in 0 is going to be the easiest number to plug in. So for H, I'm going to go ahead and plug in 0. Here, I'm just going to go ahead and set it up as M equals 3/4 times H. I'm going to put a big parentheses there so I can plug in anything. Here, if I plug in 0, okay, what would M be? Well, M would be 3/4 times 0, which I would say is 0. So I'm going to go ahead and plot my point at the origin. So far so good for proportional relationship. And just real quick, we know it's a proportional relationship based off of the equation because it is in the form of y equals kx. Now, some of you might say, oh, let's try a 1 to plug in for H, okay? If I use a 1 here, M would be 3/4 times 1, which is 3/4. Is this wrong? Absolutely not. This is going to work. I would have to go up 1 and then plot 3/4. Now, is that preferred? For me, no. Okay. I would think there's a better number that I can plug in so that I can avoid these fractions. I think 4 might be a better choice, so let me try that. If I plug in 4, what happens? Here, you're going to notice the 4's cross cancel. Okay, and I would be left with 3/1, which is 3. Now, is this preferred? Definitely, because I'd rather you work with whole numbers than fractions. Is working with fractions wrong? Absolutely not. Okay, so here, I'm going to go ahead and plug in 4 over to the right 4 up 3. Now the next point, what should I use? Well, I'm going to actually use 8. And why? Let me show you. If I use 8, I'm going to notice 4 and 8 have something in common. They have a 4 in common. So 4 divided by 4 is 1. 8 divided by 4 is 2. So here, M would be 3 times 2/1, which is just 6. So now I can plot that point, 8, 6. And last but not least, what's another number I can try? Well, I can try the number 12. Now, what happens with 12? Here, I can cross cancel. 4 divided by 4 is 1. 12 divided by 4 becomes 3. And M equals 3 times 3/1, which is just 9. I plot that point. Draw my line straight through, and again you want to try to make sure your line extends through the graph. Okay, make sure you have a little arrow at the end. Now, do things look good? Definitely. Why? Because it goes through the origin and it's linear. Now, why did I choose all of these numbers? Okay, I chose all of these numbers so I can get whole numbers as an output. But how did I come up with 4, 8, and 12? If you haven't already noticed yet, what I purposely did was I took a look at my denominator and I made sure to choose multiples of the denominator. So this is a really good note to write down. Okay, if you ever have a fraction, if you multiply, if you use multiples of the denominator as an input, you will end up with a whole number instead of a fraction. Okay, so now let's ask the question of what is the unit rate? Well, here the unit rate is 3/4 miles, because that's y. Okay, miles per hour. And again, I did that because my ratios are set up as y/x. Now, does it make sense to say 3/4 miles per hour though? No. So I'm going to go ahead and, for it to make a little bit more sense, I'm going to convert it into a decimal. So I'm going to say it's 7/500 miles per hour. Okay, so now we can move on to the next problem. So for this one, what I'm going to do is I'm going to help you set it up, and then I'm going to have you decide what are some good numbers to use as inputs so that we can end up with whole numbers instead of, in this case, decimals. So here we have V equals 2.5W. Well, what number should I multiply it by? If I multiply it by 1, I know for a fact I'm going to be left with 2.5, which it's not horrible, but I would rather have a whole number versus a decimal. But I kind of jumped the gun. First number you want to try is definitely 0. Okay, so if you plug in 0 in for W, you're going to end up with 0. So I'm going to go ahead and plot that point at the origin, so far so good. I expect that for proportional relationship. Now, like I said, 1 might not be the best choice because 1 times 2/5 is going to give me 2, sorry, not 2/5, 2.5. 2.5 is not wrong, but I would prefer whole numbers. So how do I do that? Well, another way of writing 2.5 would be V equals 2.5 W. So if you remember from the previous slide, I told you if you want to avoid using avoid getting outputs that are fractions, you want to multiply by multiples of the denominator. So here, since my denominator is 2, I might want to use multiples of 2. So 2 times 0 is 0, 2 times 2 is, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. So I'm going to go ahead and input these values in for W and see what my output for V would be. So at this point, go ahead and pause the video and try graphing this on your own. Okay, so now we're back. So let's see what we get. Here I have V equals 2.5 times W. Okay, but I'm going to go ahead and replace W with some values. Now, here, oops, I'm going to plug in 2 for W. Okay, so what's 2.5 times 2? The answer is 5. So I'm going to go ahead and plot that point, 2, 5. So there's my first order pair after 0, 0. Now, what if I plug in the next value, which we chose as 4? What if I put a 4 here? 2.5 times 4. Okay, let me teach you something. When you're multiplying by decimals, multiply them as whole numbers. Okay, and then afterwards decide how many decimal points there are, then move at the end. So here, what's 25 times 4? 100. Now how many decimal points are there? 1. So my answer is 10. So there's a quicker way of multiplying with decimals. Now the next number I'm going to try is 6. So here, I'm going to go ahead and plug in a 6. So what's 25 times 6? Well, 25, I think of quarters. If I had 6 quarters, how much money would I have? I would have $1.50. Well, how many decimal places should you move? Once. So this is going to give you 15. Oops, I got excited there and I forgot to plot my point. 4, 10 would be here. And then 6, 15 would be here. Now, as I draw my line, I want to make sure it extends. Let's make that a little bit better. Make sure it extends through the graph, and we don't want to, for example, we don't want to stop here. This is not good enough. We extend through the graph and draw an arrow to indicate that this line goes on forever. Okay, so at this point, what I'd like you to do is go ahead and pause the video, and using the tip that I taught you about choosing some inputs that will create whole numbers versus fractions or decimals, go ahead and try this problem on your own. Okay, so now we're back. So hopefully you remember the tip and you chose multiples of 3 to go ahead and make sure you were left with whole numbers versus fractions. So first things first, always use 0 as an input. You would end up with 0, which means it goes to the origin. The next number I would have chosen is 3, which would have given me 5. So over 3 up 5. The next number I would have chosen would be, again, a multiple of 3, so the next one would be 6. When I plug that in, I end up with 10, so over 6 up 10, plot my point. And last but not least, in this case, I'm going to choose another multiple of 3, which is 9. And that's going to give me 15, so it's going to be over 9 up 15. And then I'm going to extend my line through the graph. Now, just a quick note. If I were to choose 12 instead of 9, would that be wrong? No, absolutely not. Okay, but it is preferred that you pick smaller numbers just in case, because you're more likely to get a number that might fit in your graph. The higher you go, the larger your number might be, and it might fall off of your graph and you won't be able to graph it. Okay, could I have plugged in 1, 2, 4, 5, 7, and 8? Definitely, but you would be left with a fraction, and you might not be able to graph those as accurately, so it's not wrong, but it's definitely not preferred. Okay, now let's talk about the unit rate. What is the unit rate? Well, the unit rate is 5/3. Okay, 5/3 what though? It's gonna cost 5/3 for every apple. But you know what? In real life, we don't say that. We don't refer to money as fractions. In fact, we refer to it as in terms of decimals, rounded to the nearest hundredth. So in this case, I would convert this into a decimal and say that it's $1.67. So $1.67 per apple. Now, real quick, I want you to think that is one expensive apple, okay? Don't just accept the information. I want you to analyze that piece of information. Why in the world should an apple cost $1.67? That is not reasonable, okay? So now, moving on, let's take a look at number 9. Now here the instructions say find the appropriate equation for the graph. So first things first, I want to collect some collect some ordered pairs. So here I see 0, 0. It definitely goes to the origin. So right now I know for a fact it is going to be a proportional relationship because it is going through the origin and it is linear, which means it's going to follow the form y equals kx. So now it's just a matter of what is my k so I can plug it into my formula. Not formula, my form. So here, let's look up some more points that I can determine here. I can see this point, which I'm going to say is 1/2, 3. So I'm going to fill it in 1/2, 3. Now moving on the line, I see 1, 6. Okay, we'll come back to this point because this point's very important. And the next point is 1.5, 9. So here, what is my constant of proportionality? There's different ways you can do it. You can definitely set it up as y over x, so 3 over 1/2, 6 over 1, 9 over 1 and 1/2. In fact, 6 over 1 is the easiest one. What's 6 over 1? 6. But there's another way, okay? Since it's a proportional relationship, it follows the y equals kx. But a key thing to know is if you look for 1, k, you can find our constant of proportionality. So in this case, it's 1, 6, which means 6 is k. So let me prove my point here. So 6 would be right here. So 1, 6. So if 6 is k, my form is going to be y equals 6x. So here, every single time you're multiplying by 6. Here, if you divided your ratios, you would end up with 6. So my equation is y equals 6x. But what does it mean? What is my unit rate exactly, and what does that represent? Well, my unit rate would be that it will, you're able to carve 6 pumpkins, remember y over x, so 6 pumpkins for every hour, for every 1 hour. Okay. So now I'm going to go ahead and move on to the next problem. Here, now what I want you to do is go ahead and pause the video and try this one on your own. Okay, so now we're back. So first of all, I want to take a look that I do have a proportional relationship. How do I know this? Well, it's first of all going through the origin and it's linear. So it's definitely going to follow the form of y equals kx. So I'm going to collect some points now. I see it goes to the origin, so I'm going to put 0, 0. The next point I see is right here. So I'm going to say that's 3, 200. The next point is here, which is 6, 400. Now that's the last point that I can see. None of the points after this is a nice number that I can definitively say is accurate. So what is the constant of proportionality? So again, you can set it up as y over x. Okay, you want to look for 1, k. So here, 1, k would be approximately here. So just by looking at it, I'm going to estimate that it's about like anywhere between 50 to 60, probably maybe 50 to 70. So now what I'm going to do is I'm actually going to compute what it is because I can't say 100%. It's like 51, 53. I can't. So I'm going to go ahead and set up my ratio as y over x. And that's how I got 200 over 3. Y is 200. 3 is x, so it's 200 over 3. Now here I would be, in the second one, I would be multiplying by 200 over 3. But how did I get that? Well, if you set it up as y over x, you would have 400, which is y, over 6, which is x, and this would reduce by 2 in the numerator and denominator and would still give you 200 over 3. Pardon my very sloppy handwriting. But my point is, here, finding the constant proportionality by looking at our ratios, we would find that our constant proportionality is 200 over 3. Notice is using 0 and over 0 is not going to be helpful for us at all, so you never want to use that point to try to determine our constant proportionality. But again, you set it up as 200 over 3 or 400 over 6. Either way, you're going to reduce it down to 200 over 3. So following the form of y equals kx, I'm replacing that k with 200 over 3. And to prove my point, if you did divide 200 over 3, it would be about 66.7. So that does fall around this area right here. So I'm pretty sure it's correct. Now if I had 500 or 200, then I'm pretty sure it's off because that doesn't fall within this range that I kind of estimated here. But what is a unit rate? Well, it means for 200 over 3y, because there's no units, I just call it y, for every 1x. Okay? So now here, what I'm going to have you do is go ahead and pause the video and try this one on your own. So for this example here, I know for a fact it's a proportional relationship because it's linear, it goes through the origin, so it's definitely going to follow the form y equals kx. So here, let's collect some data points, some coordinate pairs. I'm going to recognize it goes through the origin, so 0, 0 is first. Then I see that it goes to 2, 8 tenths, or in this case, 80 cents. The next one would be 4, $1.60, which I'm just going to put 1 and 6 tenths. Then I have 6, $2.40, which I'm just going to write as 2 and 4 tenths. Now, what am I going to do to find the constant proportionality? Well, first of all, again, it's going to follow the form y equals kx. I'm going to, just to see approximately where k is going to follow, I'm going to look for 1, k. It's not a nice number, but it's going to be under 80 cents for sure. You want to keep that in mind, okay? So let's set up our ratios. Here you're going to see that I set up my ratios as y over x. Put it right here where I have space. So if y is 8 tenths and x is 2, if I divide this, you're going to end up with 4 tenths. Same thing here. If you had 1 and 6 tenths divided by 4, it would be 4 tenths. 2 and 4 tenths divided by 6, it would be 4 tenths. So, once again, do not use 0. You're not going to be able to find the constant proportionality that way. 0, 0, that is. So, once again, you're setting up your ratios as y over x, and no matter which ordered pair you chose, you would end up with 4 tenths. So, my equation is y equals 4 tenths x in order to follow this form of y equals kx, since k is 4 tenths. Now talking about the unit rate, what is it? Since we're talking about money, we're not going to say 4 tenths, we're going to actually say 40 cents, okay? So it's going to cost 40 cents per minute. So again, it's y over x. And there you have it. So now we're going to move on to our very last example. Okay, here I'm just going to go ahead and show you what you would do. First of all, it is a proportional relationship because it goes through the origin and it's linear. So I know it's in the form of y equals kx. So here, collecting some points now, I'm going to say it goes through the origin. So that's 0, 0. The next point I see is 1/2, 4. Since these are going by sixes, I want to keep that in mind, and these are going by halves. The next one is going to be 1, 8. Next one's going to be 1.5, let's see, since they're not going by 8. This is increments of 4. I apologize. Correction, they're going by increments of 4, so this would have to be 12. Now, did you have to pick these points in particular? No, if you wanted to, you can pick the 1, 8, 2, 16, 3, 24, 4, 32. I would have picked those just because there's no decimals involved, but I want to still expose you to, if you did have decimals, what you would do. So in order to find the constant of proportionality, you're going to set it up as y over x. So I'm going to go ahead and just write it right here. because I have space, I'm going to put it as y over x. So in this case, let's choose a nice one like 8 over 1. In fact, let me back up for a second. If I asked you what's the constant of proportionality, okay, it's in the form of y equals kx for sure. If you looked for 1 comma k, you would have found it right here, 1 comma 8. So I actually jumped the gun. I didn't have to look at the table and set up my ratios. It was on my graph to begin with, 1 comma 8. So if this was 8, 1 comma 8, that means the constant of proportionality is 8. So my equation is y equals 8x. Okay. Every time you're multiplying by 8 to get the value. But again, you could set up the ratios, but you definitely want to check your graph before you go ahead and start checking your ratios as y over x. So my equation again is y equals 8x, but notice here, why did I pick C and why did I pick S? Well, because they labeled my y-axis as C and they labeled my x-axis as S, and that's why I wrote it as C equals 8x. But once more, let's talk about the unit rate. Okay, what is a unit rate? Well, it's 8, but what are the units? It's going to be $8 per number of sales or per sale. Okay, and there you have it. That's all there is to graphing. And once more, thank you so much for tuning in. Until next time, bye.